I will speak with this one. Nidal Mahmoud from Palestine and the team. The presentation is groundwater quality of the main drinking water wells tapping the mountain aquifer of the West Bank, Palestine. And the presentation will be given by Dr. Petruševski. Just a second.
Just a second. Nidal Mahmoud. Yeah, this one.
Basically, Dr. Nidal Mahmoud could not reach Belgrade due to logistic reasons, and he asked me to try to share with you his results. I'm not a hydrogeologist, so I'll try to go through these slides that I received just maybe a few hours ago. So basically, the study was about the quality of drinking water from small wells supplying drinking water to small communities in the West Bank of the Palestine. A study was done jointly by the Belgrade University, by Palestinian Water Authority and UNESCO IHE in Delft. Groundwater is the main source of drinking water supply in the West Bank and Gaza Strip of Palestine, and about 90% of the drinking water is basically based on the groundwater resource. The main aquifer system of this area is basically spread in 3 different parts. This is a west part of the western part of the aquifer, eastern part of the aquifer, and also the northeastern part of the aquifer. This basin basically includes both shallow aquifer, but also the upper aquifer. So these two are basically tapped for water supply. Drinking water is a serious issue in the West Bank, and basically due to political and other conditions in the region, the Palestinians are very stressed, and basically they have maybe one of the lowest amount of fresh water available. At present, in the West Bank, they use only about 70 liters per capita per day. In the West, in the Gaza Strip, likely much less. The area is Mediterranean, and it is basically semi-arid, the western part, and also extremely arid eastern and the southeastern part of the country. The western part receives about 650 millimeters of rainfall, while the rest receives 100 millimeters or even less. And you can imagine that due to this limited rainfall, there is very limited recharge of the groundwater aquifer. In addition, there is a serious threat due to human activities that are affecting the quality of a groundwater aquifer. We'll talk more about this later. You can see here uncontrolled discharge of wastewater, and also disposal of a solid waste in water streams in this area. Now the water quality, drinking water quality is basically taken care of by the Palestinian water authorities, but somehow very small wells and small systems are out of their control. In addition, they are focused on a number of very basic water quality parameters, and many of the additional health relevant parameters, like for example arsenic, were not really monitored. Also, heavy metals are not really often controlled in this area. Now, the great problem is wastewater. About 94% of the wastewater in West Bank is basically disposed untreated to the environment. So in addition to that, known sources like solid waste disposal, uncontrolled, industrial wastewater, hazardous waste, and agriculture are additionally putting pressure on this resource. I should mention that only 30% of the population is linked to supply to sewage network system, but then still the most of the water collected by system is just disposed untreated to environment. So 70% of the population is using on-site cesspits for their wastewater, but then this wastewater is either leaking to the groundwater, or say it's collected by tankers. Their systems are emptied, but then the collected wastewater is just disposed without any control somewhere in the environment. And you can imagine that there is very serious threat to public health. And that's why basically there are increasing signals that groundwater pollution is really, say, becoming a serious issue. Now we wanted to say in this study to just screen water quality in a number of small wells spread over the different parts of the Palestine. The wells which are already used as a drinking water supply source. You can see location of the wells on this map. Now, as I mentioned, these are, say, wells used for domestic water supply. They are spread over the whole of the West Bank, and they, say, cover 3 different groundwater basins, as I mentioned, Western, Eastern, and Northeastern basin. And we also, say, wanted to see how the different aquifers, the upper and the lower, say, are affected. So basically, the samples were taken from both say, aquifers. Now, the wells from a really shallow aquifer are not taken into account because simply people already know that they are so polluted that it is not really, say, wise to use them for a domestic water supply. They're mainly used for irrigation, which also could impose threat. So in total, 29 wells were, say, included in the study. Samples were collected and analyzed for a number of parameters based on the standard lab procedures. The depth of the well, which was, say, part of the study, were, say, from 150 meters up to almost 900 meters. Now, this is one of the tables that provides some say, idea about the general water quality, some general parameters, and you can very easily, say, see the high levels of calcium, magnesium, and bicarbonate. So this is suggesting, say, the water type that they have, but also, say, levels of chloride and sodium are, say, you can see it here, but they're say, you can see they're elevated. So in general, say, the nature of water reflects the limestone aquifer type of the water. The TDS and conductivity of these wells is not very high, so that it's low, so up to 600 microsiemens centimeter, or about 450 milligrams per liter. Most of the wells have predominant calcium and magnesium, with the, say, bicarbonate as a predominant, say, anion, and basically concentrations of potassium and sulfate are not very high. Now we try to make also some correlation to see which parameters they possibly correlate and to learn something from these correlations. And basically what we could find is that there is a very strong correlation between the sodium chloride and the, say, sodium and chloride, and sodium and TDS conductivity, and chloride and TDS and conductivity. So it's clearly that these compounds control the TDS. Further on, say, we could see that there is some less significant correlation between the nitrate and conductivity, or TDS, and also, say, nitrate between the nitrate and the sodium and chloride. Now these results show that TDS of the water is basically a function of the sodium and chloride. That there is no strong correlation between the, say, other parameters like calcium, magnesium, bicarbonate, and TDS. And there is only moderate correlation between the nitrate and conductivity, TDS, sodium, and chloride. Now this suggests that basically nitrate could have the same origin as the sodium and chloride. Now, high elevated sodium and chloride are likely not coming from the intrusion of seawater, because sea is not so nearby. And basically this is suggesting that likely there is some contamination of the wells used for drinking water supply with, say, likely wastewater in the area. Now, basically, the water types that were, say, found are the alkali groundwater with the calcium, magnesium, bicarbonate type, which is say coming from the recharge of the groundwater, and also say sodium chloride rich groundwater, which is say likely coming from the wastewater pollution. And you can see this on the Piper plot. There are say clearly two types of water, so the chloride and also say the alkaline water on the left part. Now the lower aquifer is showing a very different composition from the upper sea aquifer, and the correlation between sodium chloride, sodium and TDS, chloride and TDS is more significant for the upper aquifer than for the lower part aquifer. Now this again suggests that the increase in TDS is not natural process, but it is likely, say, consequence of the some artificial intrusion, or say the recharge with say untreated wastewater that could say cause this composition. Now again, two types of water, say alkaline groundwater, which is natural groundwater due to recharge, and also the wastewater, which is coming, say, on the Durov plot, and basically water used represents mixture of these two types of water. Now they say TDS is not very high, so this is good. This suggests that the contribution of the wastewater is not still very high. So basically we have to acknowledge that contamination is there, but it is not really significant because of the low quantities of wastewater, and basically say this results in the still relatively low TDS and say conductivity. Now consideration of the other measured, I'm stressing measured water quality parameters, is still basically within the levels of the Palestinian national standards. The exception is high fluoride in one well. And also say we could only detect arsenic above the values of the relative organization of 10 in the one well. Still, it is below the national standard of 50, which is used in Palestine. Conclusion of these studies: so the concentrations of say measured parameter, and again I stress the measured parameters, is basically suggesting that the water is still fulfilling the Palestinian national drinking water quality regulations, with one exception of fluoride in one single well. Arsenic again is below 50, but still we have one well which is above 10, which is a internationally recognized standard for drinking water. Basically, we could also see signs of a deep water pollution from basically wastewater sources, and the say nitrate levels are also seen to slowly increase due to again wastewater intrusion, discharge, and we are slowly approaching levels of 50 ppm that could be say of a serious problem for the future. And presence of other non-measured parameters simply cannot be excluded, and maybe say some more detailed study will show that we have additional micropollutants. Finally, just to acknowledge the support of the Dutch government to this project. And thank you for your attention.